Hello guys, today we'll be looking at the Spearman rank correlation. So the Spearman rank correlation is another method of estimating a correlation coefficient. The formula is given by rho is equals to 1 minus 6 summation di squared all over n bracket n squared minus 1. Okay, where n, this n here is the number of pairs x comma y in the data. This d is the difference between the pairs of rank. D is equal to Rx, which is rank of x minus rank of y. In a Spearman rank correlation, you rank the variables in you can either rank it in ascending order or a descending order, or depending on the order of their importance, any one. So but here we'll be using we will rank our descent in ascending order, okay, ranging from 1 to number of observations that we have. We have 8 number of observation. The example says we should compute the Spearman rank correlation coefficient of x and y using the data below. This is the data here. So they say we should compute the Spearman rank correlation coefficient, and the formula is given as rho is equals to 1 minus 6 summation di squared all over n bracket n squared minus 1, where I say that n is equal to number of pairs x comma y in the data. So we're going to rank each of these, our y and also our x. We'll be ranking them in ascending order from order of 1 to 8, because we have total of 8 observation. So this is our rank of x. Let's represent it with Rx, the rank of x. The smallest number in x is what? 1, so it will take the value 1. The second one is 3, which is 2, 4, 2, 3, 4, 5, 6, 7, 8. Okay, we will rank our y. Let's use Ry. So our Ry, the smallest value in y is what? 2, so it will take 1. The second one is 3. Now here we have 4 and also 4. So the rank that's supposed to be here is 3 and 4. But since we have the numbers are the same, so you add that rank, which is 3 plus 4, and divide it by 2. So here we have 3.5 and here we have 3.5. Okay? So the next one we have what? 5 here, 6, 7, and 8. So we ranked these in ascending order of magnitude. So the next thing we're going to do is what? To get our D, where D is equal to the difference between these two ranks. So the difference between Rs and Ry is our D. So our D is equals to Rx minus Ry. Rx, our D is equal to Rx minus Ry. Okay, so 1, this is at the rank R1, Rx and Ry. 1 minus 1 will give us 0. 2 minus 2 will give us 0. 3 minus 3.5 will give you minus 0.5. 4 minus 3.5 will give you 0.5. 5 minus 5 will give us 0. 6 minus 6, 0, 0, 0. Okay? Now, the next thing is what? Our d squared. So, which is each of these squared. D squared will give us a di squared. 0 squared will give us 0. Okay? 0 squared will also give us 0. Minus 0.5 squared will give you 0.25. 0.25. 0.5 squared will give us 0.25. 0.25. 0 squared, this was give us 0, 0, 0. Okay? The formula says rho is equal to 1 minus 6 summation of di squared, which means this summation means we are going to sum our di from this to this. So if you sum them, it will give us 0.5. So the sum of our rho is equal to 1 minus 6 summation di squared all over n bracket n squared minus 1. Our n is equals to 8. Okay, because we have 8 pairs of observation. So our summation di squared, we have it to be what? 0.5. So we simply put it in this formula. We have our rho to be equal to 1 minus 6 multiplied by 0.5 all over 8 multiplied by 8 squared minus 1. 8 squared minus 1. Okay. 8 squared minus 1, which will give us is equals to 1 minus 6 times 0.5 will give us 3 all over 8 squared is 64 minus 1 is 63. 63 times 8 will give us 63 times 8 will give us 504. Okay, 504. Okay, so this is equals to 1 minus 3 over 504 will give us 0.00595. So if you subtract, you have that our rho, this implies that our rho is equals to 0.994. So this is the Spearman rank correlation coefficient, which is the value that determines the extent to which two variables are related. So having the Spearman value to be 0.994, which is very, very close to 1, it simply shows that there is a strong positive correlation coefficient between the variables under consideration, which is x and y. Okay, thank you guys. So any question, you can drop it in the comment section. Okay.